Today we are going to see about different grafting techniques practiced in horticultural crops. Grafting is an art of joining parts of two independent plants in such a manner that they unite and grow together into a single independent plant. The parts of graft combination, which is to become the upper portion or the shoot system or top of the new plants, is termed the scion or cion. The part which is to become the lower portion or the root system is the rootstock or understock or sometimes just stalk. Reasons for grafting. When other methods are not successful in perpetuating a clone, example mango and sapota can commercially cultivate by grafting. Plants propagated on their own roots may be weak, susceptible to pest and disease or any adverse environmental condition. Rootstocks are available which tolerates the above factors. Self-fertile trees may be grafted over self-sterile tree to overcome pollination problems. The roots, trunk or large limbs are damaged, which can be met by bridge grafting. To convert poor trees into more desirable ones through top working. For fancy purpose, different scions may be grafted into the same plant. To modify the growth of the plant as dwarf, one by employing suitable dwarfing rootstocks. Disadvantages: experienced labor, wise selection of scion and rootstock, different combinations for cropping season, excessive vegetative growth, high price, increased incidence of physiological disorder. Advantages: yield, disease tolerance, nematode resistant, temperature tolerance, salt tolerance, ornamental values for exhibition and education, pest resistance. Additional terms involved with grafting. Vascular cambium. Vascular cambium is a thin tissue located between the bark and the wood. Its cells are meristematic, that is, they are capable of dividing and forming new cells. For successful graft union, the cambium of the scion is placed in the close contact with the cambium of the rootstock. Callus. Callus is a term applied to the mass of parenchymatic cells that develop from and around wounded plant tissues. It occurs at the junction of a graft union arising from the living cells of both the scion and rootstock. The production and interlocking of these parenchymatic cells consist one of the important steps in callus bridge formation between the scion and rootstock in a successful graft. Outer bark, phloem, cambium, sapwood and xylem. Elements for successful grafting. There are 5 important elements for any successful grafting operation. These are: the rootstock and scion must be compatible. The vascular cambium of the scion must be placed in an intimate contact with that of the rootstock. The grafting operation must be done at a time when the rootstock and scion are in the proper physiological stage. Immediately after completion of grafting, all cut surfaces must be protected from desiccation. Proper care must be given to the grafts for some period of time after grafting. Types of grafting. Mainly in grafting, there are 2 types: attached scion methods of grafting and detached scion methods of grafting. Attached scion methods of grafting, the scion is still attached to the mother plant till the graft union takes place. Detached scion methods of grafting, the scion is separated from the scion plant or mother plant just before grafting. Simple inarching or approach grafting. The distinguishing feature of this method of grafting is that 2 independent plants on their own roots are grafted together. The two plants will be on their own roots till the formation of successful graft. Example, mango sapota. Procedure. Select a healthy shoot of having a 3.5 cm girth on the selected mother plant, which is to be used as a scion source. Select a rootstock having approximately the same size as that of the selected shoot on the mother plant. On the internodal region where the union is to occur, a slice of bark and wood 2.5 to 5 cm long is cut from both the selected stalk and scion shoots. The cut should be perfectly smooth so that a close contact of the cambium layer of the stalk and scion is brought about when they are pressed together. Tie the two cut surfaces together tightly with string or cloth. The union is covered with a mixture of cow dung and mud in equal parts. After 6 to 8 weeks, the top of the rootstock is removed above the graft point and the base of the scion is removed below the graft point. Removal is done in stages by giving a half cut and first and another half cut after an interval of 10 days. Veneer grafting. This is a kind of side grafting with slight modification. It is used widely for grafting small potted plants and in situ grafting. Example, avocado, mango, etc. Procedure. On the stalk plant, at the desired height in the internodal region, give a shallow inward cut running to a length of about 2.5 to 5 cm. At the base of the first cut, make another short and inward cut intersecting the first cut and remove a piece of wood and bark. On the scion, towards the base, give a long slanting cut towards one side and another short inward and downward cut on the opposite side. The cuts given on stalk and scion should be of same dimensions so that the cambium layer can be matched as closely as possible. Insert the scion onto the rootstock such that a contact of the cambium is established at least on one side and tie them firmly. After the union has healed, cut back the stalk above the graft union either on gradual steps or all at once. Remove edges from rootstocks, fit scion into place, wrap union and seal with wax. Epicotyl or stone grafting. This method of grafting is done on the epicotyl region of the young seedlings, hence the name epicotyl grafting. Example, cashew, mango, etc. June to September is the best period for epicotyl grafting. Procedure. Select very young seedlings about 10 days old raised in polythene bags of size. Cut off the top portion of the chosen seedlings, leaving 5 to 6 cm long shoot. With a sharp knife, make a vertical downward slit at the center of the remaining portion of the epicotyl. Select a dormant 3 to 4 months old terminal shoot of about 5 to 8 cm long from a proven mother plant as the scion stick. Cut the lower end of the selected scion to a wedge shape by giving slanting and inward cuts of 2 to 3 cm on opposite sides. Insert the wedge-shaped scion in the slit made on the seedlings and secure firmly with polythene strips or tape. Water the graft regularly without wetting the graft reunion. In about 3 weeks, the scion starts sprouting. Softwood grafting. It has been developed to graft small and young rootstocks which are grown in situ or in pots, example cashew and mango. Procedure. Raise the rootstock seedlings in suitable containers or preferably in the main field itself where the grafts are desired to be grown and allow them to grow for a year or more. When the seedling attain a height of 30 to 45 cm, decapitate the top portion of the fresh growth on the stock plant with a knife, retaining about 8 cm of the fresh stem. Make a longitudinal cut of 3 cm in the retained fresh stem. Select a cion stick of about 10 cm long and about the same thickness as of the prepared stem on the stalk. Cut the basal end of the cion to a wedge shape of about 3 cm long by chopping the bark and a little wood on two opposite sides. Insert the prepared wedge part of the cion stick into the slit made on the stalk and secure firmly with polythene strips. Water the grafted plant regularly. The cion sprout in about 3 weeks. Splice grafting. Splice grafting is used to join a cion onto the stem of a rootstock or onto an intact root piece. This simple method is usually applied to herbaceous material that callus or knit easily, or it is used on plants with a stem diameter of ½ inch or less. In splice grafting, both the stalk and cion must be of the same diameter. Preparing the stalk and cion. Cut off the rootstock using a diagonal cut 3/4 inch to 1 inch long. Make the same type of cut at the base of the cion. Inserting the cion. Fit the cion to the stalk. Wrap this junction securely with a rubber grafting strip or twine. Securing the graft. Seal the junction with grafting wax or grafting paint. Water restocking, sparkling until the graft knits. Overwatering may cause sap to drown the cion. Be sure to remain the twine or strip to as soon as the graft has healed. Whip and tongue grafting. The whip and tongue technique is most commonly used to graft nursery crops or woody ornaments. Both the rootstock and cion should be of equal size and preferably not more than ½ inch in diameter. The technique is similar to splice grafting, except that the whip on the rootstock holds the tongue of the cion in place and vice versa. For the whip and tongue grafting, make similar cuts on both the stalk and cion. Preparing the stalk and cion. Cut off the stalk using a diagonal cut. The cut should be 4 to 5 times longer than the diameter of the stalk to be grafted. Make the same kind of cut at the base of the cion. Next, place the blade of the knife across the cut end of the stalk, halfway between the bark and pit. Use a single knife stroke to draw the blade down at an angle through the wood and pit. Stop at the base of the initial diagonal cut. This second cut must not be followed to gain the wood but should run parallel to the first cut. Inserting the cion. Prepare the cion in the same way. Fit the cion into the rootstock so that they interlock whip and tongue. Be certain that the cambium are aligned. Securing the graft. Wrap the junction with a grafting strip or twine and seal it with grafting wax or grafting paint. Never allow the binding material to griddle the stem. Preparing the stalk. Saddle grafting. The stalk may be either field grown or potted. Both rootstock and cion should be of the same diameter. For best result, use saddle grafting on dormant stalk in mid to late winter. Stalk should not be more than 1 inch in diameter. Preparing the stalk. Using 2 opposite upward strokes of the grafting knife, sever the top from the rootstock. The resulting cut should resemble an inverted V with the surface of the cut ranging from ½ to 1 inch long. Preparing the cion. Now, reverse the technique to prepare the base of the cion. These cuts on the rootstock and cion must be the same length and have the same slope so that a maximum amount of cambium tissue will make contact when the two halves are joined. Inserting the cion. Place the V-notched cion onto the saddle of the rootstock. If rootstock and cion are the same diameter, cambial alignment is easier. Otherwise, adjust as needed. Securing the graft. Wrap the graft with a grafting twine, tape, or strip, then seal it with a grafting wax or grafting paint. Top working. Cleft graft. It is a method for top working both flowering and fruiting trees, apples, cherries, pears, and peaches, in order to change varieties. Cleft grafting is also used to propagate varieties of camellias that are difficult to root. This type of grafting is usually done during the winter and early spring when both cion and rootstock are still dormant. Cleft grafting may be performed on main stems or on lateral or scaffold branches. The rootstock used for cleft grafting should range from 1 to 4 inches in diameter and should be straight grained. The cion should be about 1/4 inch in diameter, straight and long enough to have at least 3 buds. Cions that are between 6 and 8 inches long are usually the easiest to use. Preparing the rootstock. Using a clefting tool, wedge and a mallet, make a split or cleft to the center of the stalk and down 2 to 3 inches. Remove the clefting tool wedge and drive the pick end of the tool into the center of the newly made cleft so that the stalk can be held open while inserting the cion. Preparing the cion. In cleft grafting, one cion is usually inserted at each end of the cleft, so prepare 2 cions for each graft. Select cions that have 3 or 4 good buds. Using a sharp, clean grafting knife, start near the base of the lowest bud and make 2 opposing smooth taped cuts 1 to 2 inches long towards the basal end of the cion. Cut the side with the lowest bud slightly thicker than the opposite side. Be sure the basal end of the cion gradually tapers off along both sides. Inserting the cion. Insert a cion on each end of the cleft with the wider side of the wedge facing outward. The cambium of each cion should contact the cambium of the rootstock. Securing the graft. Remove the clefting tool from the cleft so that the rootstock can close. Pressure from the rootstock will hold the cion in place. Thoroughly seal all cut surface with grafting wax or grafting paint to keep out water and prevent drying. If both cions in the cleft take, one will usually grow more rapidly than the other. After the first growing season, choose the stronger cion and prune out the weaker. Bark graft. Bark grafting is used primarily to top work flowering and fruiting trees. In contrast to cleft grafting, this technique can be applied to rootstock of larger diameter and is done during early spring when the bark slips easily from the wood but before major sap flow. The rootstock is served with a sharp saw, leaving a clean cut as with cleft grafting. Preparing the stalk. Start at the cut surface of the rootstock and make a vertical slit through the bark where each cion can be inserted. Preparing the cion. Since Multiple scions are usually inserted around the cut surface of the rootstock. Prepare several scions for each graft. Cut the base of each scion to a 1.5 to 2 inch tapered wedge on one side only. Inserting the scion. Loosen the bark slightly and insert the scion so that the wedge-shaped tapered surface of the scion is against the exposed wood under the flap of bark. Push the scion firmly down into the place behind the flap of bark. Replace the bark flap and nail the scion in place by driving 1 or 2 wire brands through the bark and scion into the rootstock. Insert a scion every 3 to 4 inches around the cut perimeter of the rootstock. Securing the graft. Seal all exposed surface with grafting wax or grafting paint. Once the scion have begun to grow, leave only the most vigorous one on each stub. Prune out all the others. Bark grafts tend to form weak unions and therefore usually require staking or support during the first few years. Bridge grafting. Bridge grafting is used to bridge a diseased or damaged area of a plant, usually at or near the base of the trunk. Such damage commonly results from contact with grading or lawn maintenance equipment, or it may be caused by rodents, cold temperatures, or disease organisms. The bridge graft provides support as well as a pipeline that allows water and nutrients to move across the damaged area. Bridge grafts are usually done in early spring just before active plant growth begins. They may be performed any time the bark of the injured plant slips. Preparing the scion. Select scion that are straight and about twice as long as the damaged area to be bridged. Make a 1/2 to 2 inch long tapered cut on the same plane at each end of the scion. Preparing the stalk. Remove any damaged tissue so the graft is on healthy stems. Cut a flap in the bark on the rootstock the same width as the scion and below the injury to be repaired. Gently fold the flap away with the stalk being carefully not to tear the back bark flap. Inserting the scion. First, insert and secure the scion below the injury. Push the scion under the flap with the cut portion of the scion against the wood of the injured stem or trunk. Then, go back and insert and secure the scion above the injury following these same steps. Push the scion firmly into place. Pull the flap over the scion and tack it into a place as described for bark grafting. When grafting with young stems that may waver in the wind, insert the scion so that they bow outward slightly. Bridge grafts should be spaced about 3 to 4 inches apart across the damaged graft. Securing the graft. Secure all graft areas with warm grafting wax or grafting paint. During and after the healing period, remove any buds or shoots that develop on the scions. Buttress graft. This method is useful in supporting the branches or trees that are weak. They may fall or break off. A small branch of pencil thickness at about 30 cm or above the weak crotch is grafted either to the adjacent branch or to the ground for support.